Lastly, we have C. The process is still the same. Don't let the fact that C is on this side with A prime and B prime make you think that the process is any different. It's not. C now has to just cross to the other side. If you're making a reflection, everything just crosses to the other side of the line. So don't overthink that. So from C, I need to manipulate my slope, right? If I go down 1 and over 3, that's going to bring me down here. That's not really going to work. I could achieve the same slope if I said up 1 and left 3. See how I just made the bottom number negative instead of the top? They both are still equal to -1/3, but I just changed which one of these directions was my negative direction. So now I'm going to use this one, because this original slope down 1 and right 3, it would send me in a direction that I don't need to go. So instead I'm going to go up 1 and left, or backwards 3. So up 1 and left 1, 2, 3. I did that one time. So I need to do that one more time on the other side of my line. Here is my midpoint because it's on this line that's going to be the perpendicular bisector. So I'm going to go up 1 and left 1, 2, 3, and this is C prime. So line L is our perpendicular bisector of each of these 3 lines. The lines are connecting the image, the image over here to the pre-image back here. Okay, A and A prime, B and B prime, C and C prime, the corresponding parts. So now we just connect the points to make our triangle. So A goes to B, B goes to C, and C goes back to A. Okay, so let's just kind of shade that in because this looks really complicated and really busy. Our first triangle was right here. Our second triangle is the one that we have drawn. Mine is in purple. Yours might be a different color. Okay, so when you shade it in like that, you can kind of see just a little bit better how this is a reflection. Okay, we took A and B and we flipped them over to this side. We took point C and we flipped it over to this side. No matter which side of the line your reflection starts on, it just needs to move to the other side. And it needs to move in a direction or a slope that is perpendicular to the line of reflection. It also has to move a distance that's equal to the distance of the original point from the line. So in order to make that happen, we make L, or our line of reflection, whatever its name is, a perpendicular bisector of these 2 points. Now, sometimes you won't have just a random graph. You'll have some coordinates, you'll have some specific instructions. Your line might or might not be drawn for you. So up here it says the table summarizes coordinate notation for reflections on a coordinate plane. Some common lines that you might be asked to reflect across that might or might not be drawn for you would be the x-axis and the y-axis. And then you have 2 lines, line y equals x, and the line y equals -x. When you see these lines named, you need to have a picture in your head of what these lines look like. The x-axis, of course, is the one that goes side to side, and it's going to have all of your numbers marked, like this one. This is an x-axis. Your y-axis is going to go up and down, and it's going to have your numbers on the grid marked as well. So on this little example down here that I'm kind of hijacking to use for my introduction, that's your y-axis. The 2 lines down here, well, let me talk about what happens with these. On the x-axis and the y-axis, okay, if I were to flip this triangle MNP, if I were to flip it over the blue line, it wouldn't move left and right at all. The only thing that would change is that it would go from the top to the bottom. And when that happens, all you do is you change the height of the figure. So you'll notice up here, you change the sign on the Y number. That's all you would do. So if I were to reflect something across the Y-axis, like point N starts at the point 1, 4. So let me write that up here. So the point 1, 4 would become 1, -4. You'll see these coordinate notation instructions. It says you take that Y number and you make it negative. So that's what we did, 1, 4, 1, -4. We took the Y number and we made it negative. On the Y-axis, if you're flipping something across the Y-axis, that's actually the picture that we have right here of triangle N prime, M prime, P prime. So all we did, we didn't move it up and down this time, we just moved it side to side. We made it flip across from this Y-axis, or from this quadrant over to this quadrant by using the Y-axis as the middle of our flip. So on your Y-axis, you'll notice, let's do N, was it 1, 4, N prime. We can just look this up, but here is our rule that's right here, right? It says take the X number and make it negative. So without looking at our graph, looking just at our numbers, let's see if that's what happened. According to this rule, we're supposed to take this X value and make it negative. Well, our X value is 1. So let's make it -1, comma 4. And let's see if that's where our point is. So look down here, -1, 1, 2, 3, 4. There it is, N prime. So the thing to remember is if you're reflecting across the X-axis or the Y-axis, X and Y are in the names of those lines, X-axis, Y-axis, you make the opposite letter the opposite sign. So the X-axis makes an opposite Y sign. The Y-axis makes an opposite X sign. So those should be fairly quick to remember. It's these other two that I want to spend a little bit more time on. The line Y equals X goes like this. It is like corner to corner usually if your graph is a square, and it has a positive slope. Y equals -X, it goes corner to corner also, but it has a negative slope. Y equals mx plus b. They go through 0, 0, and one has a positive slope, one has a negative slope. So what that would look like on a graph like this, y equals x goes through, goes through 0, 0 and has a positive slope. Just like that. That is the line y equals x. And y equals -x is going to go the opposite direction. So see how this slope is negative, even though they both cross through 0, 0? Because these are such common lines of reflection, there's actually just a rule that you need to memorize. And y'all know I'm not a huge fan of memorizing stuff unless you have to, but this is one of those times that you need to. There is a rule for easily reflecting across y equals x and y equals -x, and those rules are right here. For y equals x, you switch your coordinates. So if I wanted to reflect point N, which is just the one that we've been using, you could do this with any point. And if N started at 1, 4, just like it has been, then N prime, what this says is we're going to take the y value and move it to the front. We're going to take the x value and move it to the back. So you switch the order. So instead of 1, 4, N prime would be at 4, 1. And that's all you do. It's a whole lot simpler if you know this rule to just manipulate your numbers as opposed to drawing it out and drawing yourself perpendicular bisectors and doing it by hand on a graph. Y equals -x says that you're going to switch that order and switch the signs. So if we are once again using n at 1, 4 as our example, n prime, we're going to switch our order 4, 1, and change the signs on both of them. These started as positive, so now they're going to end as negative. So those are your rules. Personally, the way I kind of remember it is when you have y equals x, your rule is yx. Okay, yx, yx. It's the same order of number or order of letters. So y equals x, the rule is y comma x. For y equals negative x, it's y and x, but with negatives or the opposite sign. You really shouldn't think of it as negatives because if your original coordinates are negative, they're going to end up positive. So y equals negative x, it's still the yx order, see, y and x, but you put negatives in front of both of them. So negative y, negative x. Now that's just how I remember it. You might choose or come up with something that makes a little bit more sense or is a little more eloquent, but this works for me, and I hope it does for you also. So let's do part B. We have a quadrilateral. We have D, E, F, G. Our line of reflection is y equals x. Now, if I'm reflecting it across y equals x, I want to go ahead and write my rule so that I don't have to think it through every time. I'm going to write it down and then just use this almost as a little formula sheet. So y equals x. When I have this line, it's y comma x. That is my rule. So all of these over here, I'm going to use this information to complete the chart. So if A is at xy, A prime is at y comma x. Okay, this is the same thing that we did up here. So we just switched the order. If D was at 2, 0, we're going to switch the order, so it's now 0, 2. E, 2, 2, well, when we switch them, it's still going to be 2, 2, okay? Because this is your y, this is your x. Now this one is up here, and this one's in the back. 5, 2 is going to become 2, 5. And 5, 1 is going to become 1, 5. Easy peasy. And then you can graph it. So to graph the reflection, you don't necessarily need to draw the line because you already have your coordinates. So that's kind of nice. D is at 2, 0. E is at 2, 2. F is at 2, 5. Oh, I did D wrong. D is at 0. Yeah, it is. Oh, no, I looked right here. So I'm sorry. F is at 5, 2. That's what I was doing. And then G is at 5, 1. Okay. Now we're going to graph our changed version. So D prime is at 0, 2. Label that. 2, 2 is another point. It's right here. This is E prime. F is at 2, 5. F prime. And G prime is at 1, 5. So we connect those. And you can see how you can imagine very easily the line of reflection going right through point E. The line y equals x, even though you don't have to draw it, it might be useful to see it these first couple of times. Line y equals x goes just like that. That's our line of reflection. So if we were to count out a -1 slope, I would do that 1.5 times here. And I would do that a half and another 1 right here. This would be perpendicular because of the slopes. And we would know that F prime and F are the same distance from that line of reflection. That would be true for all of our points.